Good morning, students. The last class I studied about the balancing of rotating masses when the disturbing mass is balanced by the number of planes which are of different weights on the different masses with different planes. So, in this class, we are going to discuss the problems on the method of balancing in the different planes. So, here it is the problem. A shaft carries four masses which are of magnitude 200, 300, 400, 200 kg respectively, and they are rotating at a radii of 80 mm, 70, 60, 80 mm in the planes measuring from A at 300 mm and 400 mm and 700 mm. So here in the question itself they have given the four magnitude of masses which are revolving at different radius and they are kept in a different planes. So the method is different masses are revolving and they are to be positioned at different planes. So we need to balance these four masses which are rotating. So the angle between the cranks measured anti-clockwise. So be careful with the question particularly regarding the angle representation. So the angles between the cranks which are measured anti-clockwise are A to B is 45 degrees, B to C is 70 degrees, and the C to D is 120 degrees. The balancing masses are to be placed in the planes X and Y. The distance between the planes A and X is 100 mm, and between X and Y is 400 mm, and between Y and D is 200 mm. And if the balancing mass rotating at a radii of 100 mm, find their magnitude and angular position. So here what we need to find out is what is the balancing mass, magnitude and angular position, that means theta, at where what is the position with respect to x and y or a. So first of all we need to write down the given data. What is the given data here means the magnitudes of the four masses, that is MA, MB, MC, MD. So what he has given that in the respectively manner. So we have to directly note the values in a straight manner. What is the values? One is 200 kg, another one is MA is 200, MB is 300, MC is equals to 400, MD is equals to 200. Then what is the radii of rotations? That is RA equal to 80, RB is equals to 70 mm, and RC is equals to 60 mm, RD is equals to 80 mm. But what is the units we are representing here is kg meters. So the centrifugal force we are going to calculate in kg meters. So m is in kg, but whatever the r is in mm only. You just convert these values into meters. So finally we get it the values in meters. Then once again, up to now we have noted down the given data. Then what is the remaining data is represented with the angles between the cranks measured anti-clockwise are A to B angle is 45 degrees. So here the from A to B angle is 45 degrees and B to C it is 70. So simply we can say that the successive angles of the masses are given. So we have to take a one of the masses as reference. So we can say clearly that the mass A will be the reference. So make a reference of A and draw the angular positions of the masses. So 0 O to A, that is on mass, is positioned as horizontal. For that we are making 45 degrees so that the B ball is presenting. So the diagram B, if you see the diagram B, angular positions of masses, that will shows based on the given data. Then OA is given, that is the base. Then what is the radius? For representing of the diagram, we have to take up the some suitable scales. So OA is the distance of 80, so we can representing with or meters for suitable scales. Then OB 45 degrees angle, and B to C is 70 degrees. So from B to C we just represent an angle of 70 degrees, or otherwise we can represent from A with 115. That means 70 plus 45 angle is 115 degrees angle also we can represent directly. And C to D 120 degrees. Accordingly you have to draw the diagram of angular position diagrams by representing the radii and masses. Next, the balancing mass are to be placed in X and Y. So here one more condition is that how to find out whether the problem is to be solved in the different planes. So they may give the data related to the where we have to put up our balancing mass. So here they have given that two different planes, that is X and Y, apart from the masses and radius. What is the extra planes they have given? That is X and Y. So we have to represent our balanced mass in the X and Y planes only, either X or Y. So the balancing masses are to be placed in the planes X and Y. So but where we have to position of the balancing mass means that we need to find out. So the distance between the planes A and X is 100 mm, and the distance between X and Y is 400 mm. So accordingly that we have to draw the position of planes. Position of planes diagram is to be drawn in the A. If you see the diagram, if you see the diagram A, that will represent the positions of the planes. Either we can construct from B or either construct from the question also. So then draw a horizontal line. The horizontal line and make a vertical lines of equal values what we have given in the question. So don't assume the values, you just give the values from the question itself. So accordingly question we have to position of the different masses and different planes also. So we just keep our note that from A, it is not be the A always to be left or A is always to be right, not be like that. For by trial and error method we can assumption the trial and error method we have to solve the problems. So A, B, C, D, that is a series of the masses. Okay, but where we have to place up our X and Y planes, that is our main question. So they have given that what is the data from X to A or A to X is 100 mm. So we can put up the X plane to the left side of A also, to the left side of the A, or maybe right side of the A. But what is the one more condition is that from X to Y it is 400. From X to Y it is 400. So we need to make a gap of x to y it is 400. But whatever the distance, y to d is 200. So from y to d we need to make a note of the value as 200. So firstly it is 100, again 400, again 200. Then after that, which plane is going to be off? That means either not x or y, with the only the reference planes. So which plane we are going to mark it as a reference plane? If you see x and y, either we need to choose either x or y only. But what is our main clause? That the what we are choosing the representation or reference plane to the left of that as negative, to the right of that as positive. So if you consider y as a reference plane, then how many number of negatives will be there in the left side of y? A is there, x is there, b is there, c is there. But what about x as a reference? To the left of x is only a only. So only one negative will be there. Here the negative in the last problem also we have discussed that the negative will indicate the direction only. So we can refer the y also, but no problem for the solution. The only negative means only the direction may be the change. So if you consider y as a reference and we can solve the problem, no doubt of getting the different solution. So we can exactly get what we are representing, either x as a reference or y as a reference. Both the answers will be the same, but only the difference is the direction of placing the balancing mass will be the difference. So, so here I am considering x as a reference. To the left of x there is a negative and to the right of x as positive. Then accordingly we need to go for the tabular column. Okay. Then table. This will be the table for any problem for different planes. You just remember the tabular column. After drawing the position of planes, that means after drawing the position of planes figure, then only we need to go for the table. Third step is table. Table, here what we are going to draw in the table means firstly plane, next mass, radii, centrifugal force, again difference of distance, couple. Okay, this is the diagram. Table, according to the table we need to construct the vector diagram of couple polygon and force polygon. So what is the order we have placed in the vector diagram? Here also we just copied the position of planes and angular positions diagrams. No need to go for the previous slide. Okay, here also we have make the diagrams. Okay, okay, always we have to choose up these two diagrams. So what is an order? A, again x, b, c, y, d. This is the order we are placed in the position of the planes. Same order we need to keep in the table also. A, x, b, c, y, d. And which plane is kept as a reference plane? X. So here also we just represent it in the table also RP, that means reference plane. Then what is the masses of the planes? Plane means the mass of A. What is the MA? 200. What is the MX? We need to find out. MB 300, 400, MY 200. Then what is the radii? These are all the data we have given in the question itself. So in the question, in the last line, see here, if the balancing mass revolving at a radii of 100 mm. So what is the balancing mass? Where we are going to put up the balancing mass? That is plane x and y only we have to kept it. So for both x and y we don't know where we need to put up your balanced mass. Either we have an option called x or y. So we are trying our best to do that X or Y that is given by in the question itself. Okay. So 0.1 and 0.1. Then centrifugal force. Centrifugal force means mass into radius. So mass is 200, radius is 0.08. So like that we just frame the table. After that, the distance from the plane. What plane? Distance from the plane means the distance from the reference plane of remaining planes. So A is referred at a distance of 100 mm. A is referred to a distance of 100 mm, but the negative direction. So from X, A is placed at the 100 mm, but we are going to represent all the values in meters. So convert 100 into mm, 100 mm to meters. That is 0.1. The negative sign means to the left of the reference plane. Then X same 0, 0.2, 0.3, all these values we need to get up from the information. 0.6. Next, what is the finally couple? Force into distance. So force is 16 into distance is 0.1, so 1.6. The negative sign will always be followed. So by all the values here, we are all the getting the values. So by getting all the values we need to draw what is the thing, couple diagram and a force diagram, or couple polygon or force polygon. So how to draw the force polygon and couple polygon? Based on the, this is only for actually for same plane or simple planes, we are going to construct only force polygon, that is enough. But for different planes, we need to add extra thing called couple polygon. Okay, this is only the difference. So firstly, we need to construct the force polygon by using the force all the values. So first A, for A plane, how much of force? 16. So for A plane, how the A plane was represented in the angular position? Horizontally. So OA is horizontal. So here also OA is horizontal. The force. Again, what is the force we are having here? 16. So we have to represent 16. Then again, what is the next thing? A to B. What is the second mass? A to B. That means B is positioned with respect to A. So A. Again BC, that is of 24. CD 24. After that CD, that is 21. Sorry. 16. 16. The value is 16. After that, the DE. The DE is representing to which plane means the MY, that means Y plane. After that, finally we go for the X plane. So we have to kept these things aside. So we are keeping at a distance aside. So again we have to go for the couple polygon. Couple polygon. These two diagrams will be kept uh, aside in a single page only. So with that we can find out the values in a easier manner. So draw a couple diagram. Then we have to consider the couple values. So if you see the couple values, how many couple values are there? Only 1, 2, 3, 4, 5 only, not 6. Here one thing was 0. So we have to construct the couple polygon. That is from A. So the couple polygon also for plane A. For plane A, how the axis is there? OA, it is in horizontal. So from 0 to A. But what is the direction we are keeping here? That is reverse, that is left side. Since we are making a sign as negative, so here for negative we are representing the direction to negative side, so in the left side. What is the value? 1.6. Here also we need to take the suitable scales 0 to a dash with the value 1.6 in the negative direction. After that, what is the position called? 0 is there, no need to worry about the 0, so we can directly eliminate, no value is there. So next 4.2, 4.2. What is an angle? 45 angle. So we can directly change up to 45. And after that it is 7.2 with angle 70 degrees. After that 120 degrees with the value 0.9.6. Then finally, what is the value is to be find out, that is 0.04 m by only the value it was placed finally. So from D to O is simply we have to close up the polygon. So this is called the balanced couple, that is related to 0.04 m by. So we just mark the length of this O dash D dash, that will results to 7.3 kg meter, that is equal to 0.0474 m by. So from couple polygon we can directly draw this 0.04 my is equals to vector d dash o dash, that is by measuring the values with the scale from the suitable scale. So 7.3 kg meter. So directly we can get it m by is equals to so and so. Then coming to the force polygon, then force polygon already we have constructed the value as 7.3. This is the result we achieved from the couple polygon. So with the same value we just draw the same angular position, that is d dash o dash parallel to d dash o dash, draw from the force polygon where we have stopped, that is d. So from d draw a parallel line to d dash o dash, that is called E, with the length of 7.3. Then after that, what is the empty one? That is 0.1 mx, that is the centrifugal force polygon. So up to now 0.1 my was closed. So 0.1 into my, it was cleared. After that, what is the final result? From E to O, we just close up with the value 0.1 mx. So this will result the balanced force. So finally 0.1 mx is the balanced force. By using of scale, we just mark the length as 35.5 kg meter. Then mx is equals to 355 kg. So this is the procedure for solving the different polygon. So mainly thing, we have to positionate our planes with respect to the question. After that, go for the table. Meanwhile, we have to prepare the angular positions. So all these four diagrams are to be clearly. So for solving the problems, we have to use the exact scale and pencil for drawing these diagrams, and the set square is to be required. Okay, these are very simpler problems. For university questions also, they may ask very simple problems, maximally the four masses and two reference planes. Maybe this question also, which was already asked in the university examination. So try to solve or get the uh, points from the question. Okay. And finally, we have achieved mx value and my value. And what is the angular positions also, we need to mark it on the paper. That means in the sheet we have to represent. So theta y is equals to 12 degrees from the A. Okay. And theta x is equals to 145 degrees from A. Then one more problem we are solving here. Then four masses A and B, C, D, which are shown are to be completely balanced, then mass of the A, mass of the B, mass of the C, mass of the D are given, and a radii of rotations also given in that. The planes containing B and C are 300 mm apart, and angle between the planes containing B and C is 90 degrees, and BC makes an angle 210 and 120 degrees respectively with D in the same sense. So with D we are making the angle. So, and finally magnitude and angular positions of A and the position of planes A and D is to be required. So what is the question? It has given that we don't know the mass of the A. That is the one thing. We need to find out the angular position and magnitude. So A is to be find out. Okay, one thing was cleared. And the position of A and D, and that means the angular positions between A and D are where to be. So according to the question framing, we need to solve it. So firstly draw the position of plane diagram. See, let us see. Given RA, RB, RA, MB, MC, MDD, RB, RC, RD. That has given. Then what is the angle given that B to C? B to C is 90. B to D, I think so. It may be okay. B and C makes an angle of 210 with the D. So B is making angle 210 with the D, and C is making angle 120 with the D. So we have to clear about the question. So don't confuse it. Okay. Thoroughly read the question and understand the question first. So angle B D is 210, C D is 120, and the distance has given. The plane's masses B and C are 300 mm apart. So the distance between B and C are 300 mm apart. That has given. After that, draw the positional diagrams. So these are the positional diagrams and angular diagram. So firstly, B to C. So from B as a reference, draw a 90 degrees to B, that is C. From B to D is 210 and C to D is 120. So according to that, we need to draw the diagram of angular positions. So in the order that A, B, C, D, these are the four things. From B to C, that is a gap is 300. That is the position of planes. And what is the distance between B to D and B to A? That is to be find out. So from the diagrams, we can achieve that from the diagrams we can achieve this, the table of positioning. So what is the main difference is which is the thing we need to make it as a reference plane. So we can obviously we can say that A or B, since if you make a D as a reference, that entire left side will be the negative. If you consider D right side, no positive is there. So that is the one case. Then coming to A, you can mark the A as a reference. But when we consider A as a reference, the finding element, so in the question itself we need to find the mass of the A. So if you make it the reference A, that will be closed as 0, so it is always be 0. So we need to, in the question itself we need to find out the mass of A. So either considering B or C. So here I am considering B as a reference. So right side is more positive, left side is only one negative. So A, B, C, D, this is the length. So here they were not representing the different planes. So don't add x, y as the different planes by assuming. So in the question itself, they are not giving any different axis planes. So we are giving only ABCDS. So here also in the table ABCDS. And reference plane is RP, that is B. Then mass of A is 0. Sorry, mass of A is not given. So MA 30, 50, 40, radius 0.18. These are all given from the data. And again, distance from the reference plane. Distance from the reference plane. What we have given that it is no data is available, so that's why we are keeping the values as B2D is X, B2C is 300, that is already given, B2A is Y. So that is in the left side, so negative Y 0, 0.3, couple multiply all these values. Based on the couple, we need to draw the diagram. Based on the force, we need to take up the couple diagram and force diagram. So we just copied the table here, and then we draw the couple polygon. So how to go for the couple polygon diagram? The couple polygon diagram, what is the only the thing we know that A we don't know, that is negative value, and also that is a value of Y only. So Y we need to find out. Then what about the B? That is 0. We can't able to proceed. What about the C? That we know. But what about the D? Distance, which is related to Y only. So sorry, X only. So in the couple diagram, there is only the possibility with C. So that's why we are constructing the couple diagram as a reference. So from 0, then C, what is the position of C? It is vertical. So draw a vertical line with the value couple is 1.8. Then what about the remaining thing? What is the remaining thing means? What is the last we need to know that is D value. B is already over, D value only the possibility. You know, if you know the 6x, if you know the value of x, we can directly show up these values. So 6x is the value. From C to D, what is an angle? 120 degrees. So draw a 120 degrees angle. Draw a 120 degrees angle from C. So from C, draw a 120 degrees angle and you kept aside. And at the same time, from A, how much of angle is there? From A, that is we need to find out from the force polygon. So then you just left out the D or couple polygon aside and come to the force polygon. So here force polygon is A, we need to find out. So kept aside and draw B as a reference. So B as a reference means which is of length 7.2 in the right side. So 0, B, distance 7.2. So use suitable scales. And after that B to C distance is, that is centrifugal force is 6, which is perpendicular. So B to C 90 degrees 6. And again C to D, what is an angle? 120 degrees. With the 120 degrees at a distance of 6. Then finally it was cleared that B is over, C is over, D is over. What is the closing of polygon? Is A only. So join OD, you just measure the length and equate to 0.18 MA. So vector 0.1 MA is equals to vector OD, that is equals to, by measuring with the scale, it is calculated as 3.6 kg meter. With that MA was get it out. MA is equals to 20 kg. Then coming to here, the vector diagram, we just copied the same thing with the angle, that is 6x. 6x is equals to, so here how to construct this means, we already get it, the angular position of this mass A is 56 degrees. So with the 56 degrees in the couple drawing or couple polygon, draw a line of length. We don't know actually 0.18, we don't know the 6x, but we know the angle with CD, that is 120 degrees. So just simply draw a 120 degrees of infinity length of line. Since we know we don't know the value of x, if you know the x means we can multiply with the 6 and we can make up the length, but we don't know the length, but we can know the angle position. So from 6 dash to D dash, we just draw a infinity line with an angle 120 degrees from C. And what is the remaining thing? B is over, C is over, D is over. Whatever the thing is A. But here in the couple polygon, what is the A position? 0.18 MAY. Here we know from the force polygon MA value, that is 20, but we don't know why. So, but only the thing is A is presented at an angle of 56 degrees. So from O dash, draw a 56 degrees angle and meet the previously drawn C dash D dash. Just to cross out these two. That is the point where these two lines were cut it out. So we just simply draw this, and finally we get the C dash D dash length as 6x and O dash D dash length as minus 0.18 MAY. Already MA we know, Y we know need to find. So finally we get it as Y is equals to minus 1 meter and X is equals to 0.383 meters. That is the final thing. So in the same manner, we just solve all the problems. So with that, the same procedure. But the only clear thing is force polygon and coupled polygon is the mainly difference. So with that, the balancing of rotating masses problems also will be closed. These are all in the textbook itself, all the problems were discussed. So you just to copy that and make a practice on this. So with that, the session of balancing of rotating masses will be closed. So here only we are having only two models of problems only. One is by different planes, another one is same planes. So different planes means we are getting the couple diagram or couple polygon diagram. The same mass means force diagram only is enough to solve the problem. But both the cases, the very simpler problems will be given in the questions, university questions. Okay. Thank you.